Thank you all for attention. Hans-Jörg went a bit wider than I myself, so I'll go a bit more specific, just focusing on the BNG. And I'm going to describe how we see the BNG today and how we see the BNG going tomorrow. And to preempt some questions, 5 times 9 and 10 of course stands for availability, like 99.999%. So just to be sure we're on the same page here. We get that a lot actually. And usually when you buy something in a company receipt, they usually say, oh, 45, you know. So, yeah. Yeah. A little bit of self-promotion. So I've been working at telco until 2017, and in my spare time I used to write a bit of code, just so my programming skills don't, fall behind. And I built this like virtualized BNG, which a friend of mine told me, oh, yeah, why don't you just put it on GitHub? So I put it on GitHub. People started contacting me, asking me, okay, can you support us? Can you deploy it somewhere? And I told this to my colleagues, and we said, okay, there might be something there. So we got some EU funding and started our company 5 times 9 Networks, where I'm now the Chief Development Officer. So in the beginning, I was just coding, but as the company grew, we got smarter people than us doing the actual work, so I'm just now doing presentations and sales pitches, so most of the time. Just a hint, if you have an open source project, please Google the name, because I named mine Open BRS, but if you pronounce it differently, it's Open Bras. So, it's not really a safe Google search. Yeah. I'm also chair of the Network Operator Group in Croatia. So for the German colleague, it's the DNOG of Croatia. We have like a couple of times per year, we have some technical presentations, technical workshops, educations, but mostly it's just like, it's just about the community, like having just the sponsors pay us beers after the meeting. So more or less that's it. Let's start with the traditional BNG. What is the BNG of today, let's say? And first of all, no presentations can go without mentioning AI. So AI generated that picture, and this is about the AI things that a BNG looks like. This is something, so the traditional BNG is something we're all familiar with. So basically you have multiple instances, multiple independent appliances which are hardware-based, which you configure one by one, you deploy it in a location, and you have probably a BNG template for the configuration, but then you need to change the IP addresses, you need to change the SNMP communities, and you configure basically each and every one of them one by one. And God forbid if something fails, you need to remember which IP pools were configured at that BNG. You need to put on different BNGs, and it's a whole lot of manual intervention, manual work. If you want a new feature, then for the tier 1s, it's probably a bit simpler because they have better support, but for tier 2s, tier 3s, getting support and new features from the traditional BNG vendors, the big guys, it's really slow process, and basically takes some time to get. And in the end, it's probably easier to modify just your internal architecture, like radius and stuff like that, to adapt to the BNG rather to the other way around. So I know this from experience. So what has changed in the last, let's say, 4 to 5 or 10 years? So Hans-Jörg was also mentioning that there's a lot of new stuff going on, which has come to a mature phase. Like you see all these logos on my slide. So OpenStack is more stable. NFV has really come to fruition. People are using it. NenConf is being widely used. Ansible, Python. So there's all these new sorts of technologies which we can make advantage of, which you can use in building a BNG. Also, we have a lack of skilled workforce, so it has forced us actually to be more efficient because all these new tools which are available, they require a different set of skills. So it's always, we have discussion, is it easier to get a network engineer to program something, or is it easier to get the programmer to learn networking? So it's always like difficult to see how everything will go, and it's really not so common to have somebody who is really an expert in like MPLS, segment routing, something like that, who can also be really good like Python programmer or C programmer or something like that. So, and people who are really good, the software industry can like poach them. So it's really difficult to be in competition with the software industry, with the big players, and to have really good programmers who at the same time understand like MPLS and really some advanced routing stuff. The other thing that has changed is benefit explosion. So this is a slide, I think, from a year and a half ago, but it probably hasn't changed that much. So you have all these streaming services which came out like in a year or two basically out of nowhere, which made us really think about how we how we design the BNG architecture. Because maybe the standard way of building things was okay for like a normal growth, normal traffic growth, but since this benefit explosion, we need to think ahead of the game. We need to see how this how this extra benefit will affect our services. And also you have this geopolitical stuff like the higher power processes with big emphasis how much power is used, what about inflation. And for example, during COVID, I know like the big players, the traditional BNG players had like 300 days of delivery times if you wanted a new router or a new BNG. So all these things add up. And now let's talk how you want to design your BNG. So if you are designing a BNG from scratch, how does it need to look like? First of all, so it's not a popular topic in the technical community, I would say, but the management doesn't care if you're using MPLS or if you're using, for example, VPLS or EVPN for your layer 2 VPNs. The management wants to cut costs, so they're already looking at the like price to performance ratio. And if it was to us, to the network engineers, we would design the perfect solution, which was 3 times oversubscribed to cover every possible scenario. But the reality is that everybody's looking at the costs. They want to cut man hours, they want to cut the capital expenditure, the operational expenditure, and it's always like a sword hanging over our necks, you know, how much money we can spend and what is the best performance we can get out of the existing equipment and how the new equipment, what is the investment related for the new equipment. We need to accommodate for the rising demand for bandwidth. Like we said, the streaming services, the FTTH rollout. So I've seen a lot of talks here regarding FTTH, how it's going to fit to 50 gig, 100 gig. We need to accommodate for these new speeds cheaply. So you want to design a BNG architecture, which you don't have to change hopefully in the next 10 years, which you can grow seamlessly, and hopefully you can pay as you grow. So you don't have to invest in the beginning for big amounts of money to be stable for the next couple of years, but you can grow once you see how the traffic benefit is growing and just expand your capacity in the steps. So hire sales and just give it to the employee just to handle it. So these are conflicting goals. You want to accommodate higher bandwidth, new service, everything, and you still want to cut costs. So it's really always a compromise, ongoing compromise when you deploy the BNG. How do we get to the end goal? How do we get to the efficient BNG? So let's look at the hardware perspective first. So we have, the first approach should be to make the traditional BNGs more manageable. So let's talk netconf yang, orchestrators, SDN. Let's use the existing routers and let's make them like, let's say, cloud aware. So let's configure them from a single point of contact. So I won't lose that much time on that. Let's focus on the other things. So we can use white label switches. So they are more flexible, let's say, than the traditional BNG. They are dependent on some hardware underlying, so either P4, Broadcom API. I would say more Broadcom because it's like the prevailing solution nowadays. And they have low power consumption. The third thing you can do, you can deploy commercial off-the-shelf x86 servers. So you can go in a store, buy any old server, and you can deploy the BNG on your x86. You have the maximum flexibility there, and there's no hardware dependency. So you can basically buy from any vendor you like. And let's just focus on the comparison between the white label switches and the x86. So I've managed to put down a couple of points which I think are the most interesting ones. So let's just go through them quickly to see the differences. So regarding the throughput, there's a no-brainer. So the white label switches are definitely in the advantage, so that they have like multi-terabit speeds, while the x86 has a 1 terabit speed, let's say roughly 1 terabit speed, but we'll get to x86 later on. Subscribers, for the white label switches, it depends on the RAM. It's getting better, I see it, but still you can get around, I would say, 50,000 subscribers on a single white label switch. Of course, depending about the quality of service requirements and how much the queue depth needs to be for each and every subscriber. So it's a compromise there. For the x86, well, you can put probably 2 million subscribers there, but the more you put subscribers, the less performance you get. So you get the flexibility, it depends on the memory, but yeah, it's much better, let's say, than the white label switch. Regarding the port count, of course, the white label switch has a high port count. It's easier to deploy, for example, on the edge. But even the x86 is getting better. So we know some vendors which take x86 servers, build them in a bit different form factor, and they can support like in a 2-rack unit. For example, we've seen support for 32 10 gig ports and 4 times 100 gig uplinks. So it's not as perfect maybe as the white label switch, but it's getting there. So there are some. It's not exactly off the shelf, but it is something you can be used in production. The power consumption is definitely on the side of the white label switch. It's now like a compromise between the number of subscribers and the power consumption, because if you have lower number of subscribers, you maybe need one switch, but if you have like, for example, 200,000 subscribers, and then if you need 3 or 4 switches, you will spend more power than a single server. So it's, yeah, depends on the use case, basically. Development and flexibility. So I would say that the advantage here is on the side of x86, because still the white label switch is dependent on the Broadcom or underlying hardware. And if there's not some feature implemented in the hardware, it might be difficult to implement it and use it on the software side. While on the x86, you basically just configure it in C. We haven't seen actually, so we're building virtual BNG, so we haven't still come across a feature that we weren't enabled to, we haven't come across a feature we were unable to build. You know? So basically you can, if you have a specification, yeah, it can be built on x86. And now the interesting slide. What happens with x86 performance? So bear with me a minute. So let me just explain this is from our lab, and let me just explain how you should read this slide. Basically, this is not the latest generation in Intel Xeon. So this is like the 4th generation. We have now the 5th generation in production, and also the 6th generation is coming up in a couple of months. This is tested with the 500 byte packet sizes, bidirectional. So if you see, where's the pointer? No, middle one. Okay. So if you see the number here, 928, that's 928 gigabit in one direction and 928 in the other direction. So in total, 1.8 terabit. So the left graph is related to the total bandwidth per server, and you see on the y-axis is basically the number of subscribers on that server. So it's related to the number of subscribers on that server. So basically, if you have like 128,000 subscribers on the server, terminated on the server, and they're not using quality of service, you will get 840 gigabits bidirectional traffic on that server. And in the worst case, if all the subscribers are using quality of service, you will get 400 gigabit bidirectional. And we have some tricks in our code that basically if subscribers are not using quality of service, and in production, maybe in the peak hour, maybe 5 to 10% of subscribers are using it, so the numbers in production would be closer to this orange bar. The right graph is basically the same graph as on the left side, but it's the throughput divided by the number of subscribers for that specific scenario. So, for example, if you have 128,000 subscribers on a server, each will have guaranteed 6.6 bidirectional traffic, 6.6 megabits bidirectional traffic guaranteed. So, and for example, there is a small performance penalty if you do asymmetrical routing, but it's like 5 to 10%. So basically, with 128,000 subscribers, you could probably do like 10 megabits downstream and 2 megabits upstream guaranteed per subscriber. You know, so I think that these are numbers really comparable with like white label switches and enough for even today. So I think even if you put 200,000 subscribers on a server today, these numbers are good enough for today's average peak values. And this is not on the latest Intel server, so it's like 2 generations behind. So the x86 has become really powerful, and we can really utilize the throughput and the flexibility of the x86 platform. What do you do with software? So we have CUPS, we have TR459, which is, yeah, it's more complex than a traditional BNG, but we get less vendor reliance. We can mix and match the control in user plane, and we can decide what is the user plane, which user plane is best for our use case. We have trended towards simplified management automation. I've talked about this before. Everybody is using the NetConf Yang. Everybody is starting to use REST API, GNMI, gRPC, and stuff like that. So things are getting along regarding that way. And also, we need to use open source tools and software industry best practices. The thing is, so we're building a virtual BNG, and we see ourselves as a software company. So if we are a software company, we need to take advantage of the trends and the best practices in the software industry. So using Grafana, the Elk stack, Kubernetes, nightly builds, the testing automation, everything that is really commonplace in the software industry, this needs to be reused in the telco NFV field. And how do we reinvent the BNG? So after all we've heard, how we want the new BNG to look like? We want single management. So we don't want to care how many BNG instances or appliances we have in the network. We want to see it, no matter if it's run on a white label switches, an x86, a Docker container, an OpenStack, or wherever. We want a single pane of glass for BNG configuration, management, and telemetry. So reporting, alarming. So we don't want to care about addressing, and we don't want to care about each and every IP address on each and every BNG instance. We want it to be automatic. We want to use different hardware related to subscriber demands. So we want to use, for example, white label switches for those places where you have like a big enterprise customers, where you have high speeds and low numbers. But we want to, for example, use x86 for like the mass market or for some specific demands which can't be done in the white label switches. And for example, we want to have a control plane for some other vendor somewhere on a private cloud. So we want to be flexible. We want to use Kubernetes for some other use case. We want to use virtual machines for some fourth use case. We want to be really flexible regarding it. This is what actually CUPS enables us to do. For everything, we want zero-touch configuration. So when we deploy a new Kubernetes instance, a new virtual machine, and when we plug in a white label switch, we don't want to configure it manually. So we want it to call home, to contact the controller, and to be automatically configured, to get all the IP addresses, to get all the IP pools, to get all the SNMP information. We don't want to do anything with it. I just want to see a new pop somewhere on the dashboard saying, okay, a new BNG is up, it's running, and everything is green, everything is working fine. We don't want to do anything with IP addresses. Like I said, we want everything to be completely automatic, like the IP pools, everything. And we want automated redundancy and elasticity. So which brings us to the next point. We want, for example, since power is a big topic now, we want the instances to spin up and spin down when we're talking about Kubernetes or OpenStack or something. We want them to spin up and spin down when there's need for additional capacity. And for example, at night, we want maybe to steer the subscribers to a couple of instances and spin down the rest of them to save power. So that is something that's really possible now. And all of this together, we call it the BNG as a service. Not necessarily because it's like software as a service or infrastructure as a service so you can resell it. But we want to manage the BNG as a service. We don't want to manage it as a series of independent ASICs. We want to just see a whole picture, like a single dashboard. We want to see all the instances. Of course, we will deep dive if there is troubleshooting needs. But if everything is green, if everything is running, I don't care what's the IP address of each and every instance. I don't care what's the OSPF neighbor of each and every instance. I just want to see if my system, if my service is working properly. So this is actually what we're building at Finance Design Networks, and this is how we see the BNG of the future. Thank you.
We gained a few minutes there. If we have a question or two on the, well, if I have one. So I don't know that you touched on it, but how does the price performance compare between the white label switches and the x86 architecture?
So in our experience, like the price is probably like roughly the same. So of like a white label switching and x86 server, so roughly the same, yeah.
And so I guess because the x86s are they're standard architecture, they could live in a data center somewhere or whatever. Is that one of the advantages? And you can turn it up and on as you need it?
Yeah, exactly. So, I mean, the white label switch is still a hardware, so it's you can put like more like edge location stuff like that. But there are also possibilities with some vendors who are making like environmentally hardened x86 servers. So it's not necessarily just in the data center, but can also go in the edge. So until now, like the main drawback of the x86 servers was the low port count. But we see that also going in the direction of higher port density on the x86, so you can go, especially with the environmentally hardened part, they can be pushed towards the edge.
Okay, here's a question.
Yeah.
Hey, thanks for the presentation. Very much in line with my thinking anyway, you know. But I have one point that I would like to challenge you a little bit on. You had this one table where you said that the amount of subscribers on the white box switches is getting better. I have a vastly different opinion on that. If I'm looking at how the chips evolve currently, it's actually getting worse.
Okay.
At least for those types of services that we are looking at Deutsche Telekom, it's actually getting worse.
Okay, thank you, yeah.
I mean,
I might not be an expert in that field, so yeah, but thank you for your comment.
it only makes your case better, I mean, so.
I didn't want to say it out loud.
So, well, again, Branimir, thank you very much for your presentation. Appreciate it.
Thank you for your time.
And yes, it is a pretty big deal, as he alluded to in his presentation.